The topic is inequalities involving the absolute value function. And we've got several of these to deal with, but let's establish a general format and how to deal with that. And then we'll go on to some specific inequalities. So, any inequality with a little manipulation can be written in this manner. And by the way, we know we can be greater than, less than, greater than or equal to, less than or equal to. And so, in general, I'm going to say, well, in this case, we'll make it greater than, and D. But the concept applies regardless of whether you're talking about greater than, less than, greater than or equal to, less than or equal to. Now, the C was chosen because it's the first word of center, or first letter of center. And the D was chosen because that's the first letter of distance. And if we were to graph this, then what value of x takes this to 0? C does. And that's our center. And what's the distance from C? Well, it's D. D, and it doesn't matter which direction we go. In fact, we've got to account for both directions. So if I go from C and add D to that, we land at, open circle, because we don't have the associated equal sign. When we have an equal sign, we'll talk about closed circles. So open circle, closed circle. So this will be C plus D. And let's see, open circle. And we're going to go C units and then subtract this distance from C and land right here. So that's C minus D. And once we get that far, we can do appropriate shading and solve the inequality. So, well, we have the inequality x minus 3 is greater than 7. So we'll graph. And now, what value of x takes us to 0? Well, the opposite of negative 3 is 3. And what's our distance? Well, it's 7. And 7. And now, there's no equal sign associated with the inequality, so we'll need open circles. And we're at 3. We go 7 more units. We'll wind up at 10. We're at 3, we'll go back 7 units, and we'll wind up at negative 4. 3 minus 7 is negative 4. Now, next issue. Where do we shade? Well, here is the story. If one point in an interval satisfies an inequality, then every point in that interval satisfies the inequality. If one point in an interval fails to satisfy an inequality, then every point in that interval will fail. So let's pick a point in this interval, and this interval goes from negative infinity to negative 4. So I'll pick a point in this interval. How about negative 10? Replacing x with negative 10, we'll have the absolute value of negative 13, which is 13, which is greater than 7. So this interval satisfies this inequality, and we shade that interval. Let's look at this interval. Well, 3 is, by the way, we only have 3 intervals, 1, 2, 3. 3 is in this interval. Replacing x with 3, we get 0. And the absolute value of 0 is not greater than 7. So This point is in this interval, failed to satisfy the inequality, therefore no point in this interval will satisfy the inequality. Now, let's pick a point in this interval, something like 100. 100's in this interval. Let's see. 100 minus 3 is 97, and the absolute value of 97 is greater than 7, so every point in this interval satisfies the inequality. Now it says give solutions in terms of set builder notation and interval notation. So in terms of set builder notation, we have the set x such that x is less than -4 or x is greater than 10. In interval notation, we're going from -infinity to -4 parenthesis and union and 10 to infinity. Now, let me point this out in case there's any confusion. Anytime you have a less than or greater than, we're going to use parentheses, and we're also going to use open circle. Anytime you have a less than or equal to or greater than or equal to, we're going to use bracket, bracket, and close circle. So,